Hello and welcome to this webinar. Thank you for joining us today. My name's Rob Lay. I'm the product manager here at Secure Logic, and we're here to talk about our technology partner, Toshiba, and their hard drives and how they fit into the surveillance industry along with the Secure Logic service. I'll take you over to Alex so he can introduce himself.
Hello, my name is Alexander Yuzunov. I'm the CTO and one of the founders of Secure Logic. My responsibilities for Secure Logic are to look after the tech and everything involves tech within the company. And company was established in 2011, and we have already 13 years of immense growth and happiness. I can not be happier working for another company because this is pretty much something like my own kid in the business.
And Rainer?
My name is Rainer Käse, Senior Manager Business Development for Hard Disk Drives. I'm located in Düsseldorf, Germany, which is the European headquarter. And I'm there with Toshiba since 31 years already. The first 20 years in the semiconductor development and R&D. And now since almost 12 years in the storage. My role as business developer is basically to make sure that everyone who is using the Toshiba hard disk drive is happy with the Toshiba hard disk drives. So this includes a lot of laboratory operation, setting up demo setups, solving customers' issues, giving good advices, but also taking care of partners like Secure Logic.
Thank you, Rainer. A quick bit about myself. My roles within the company involve a lot of working with our VMS partners, video analytics as well, testing their software on our hardware, and identifying the storage requirements as well as the many processing needs that come from the CPU and GPU these days. So I spend a lot of time doing software testing. So that's my role here, and that's why I'm here for this discussion. So I think what we'll do is we'll tackle the first question and get right to it. Alex, maybe you can start this off by discussing our relationship with Toshiba and why we use their hard drives. I would say Toshiba typically isn't the first hard drive brand that pops into people's heads when they think about hard disk drives.
Technology-wise, Toshiba is always been on the top of the wave in storage. And the most important part, especially the most important part when you produce storage for the CCTV industry, is always been reliability. Considering reliability and everything, when we start with the early MG03 series, 4, 5, 6, 7, 8, 9, and now 10, the percentage-wise, the faulty drives are negligible. That we don't even recognize them as a faulty drive. They're so small amount. And we had years we were selling 15, 17,000 drives annually. We never had more than 1/10 of the percentage, even less, faulty drives. And another good thing about Toshiba is anytime you have a faulty drive, the replacement service is extremely good, and they are not approaching this part and this service in similar way like other vendors, because if any other vendors have similar issue, they will give you a hard drive which is recertified, which is not a brand new hard drive. With Toshiba, that's not the case. With Toshiba, no matter of the fault of the hard drive, no matter of the issue of the hard drive, you always get a brand new drive, which pretty much for them is negative on the balance, but for us is positive because we always have brand new stock which we can use. We don't need to use it in a special cases or special environment. It's just brand new drive. That's a big positive plus for us. So to answer the question, I think that pretty much summarizes it in a really good way.
Okay. Rainer, do you care to talk a little bit about the relationship from your side?
From my side, from the technical part, it's, well, what Alex just said, this is not kind of a single shot for Toshiba. Yeah, we know that in order to grow our business, we need to make sure that our customers are happy with the Toshiba products, and the best way to make them happy with Toshiba products is to make them happy with the Toshiba people. So this is also part of my organization, to keep you guys happy. So whenever there is an issue, whenever there is a question, we are there for the partner, as you know. Leading technology partners like Secure Logic are on top of the list for new samples. If we launch a new series, well, for the laboratory, I have test samples, and you are always the ones who get them first in order to make yourself familiar. So this is how we support our technology partners. And I should say, Toshiba is the smallest of the 3 hard disk drive vendors. The market share is something like 40-20. In Europe, it's a little bit more. In order to grow our business, we recognized many years ago that we need to be nicer than the others. Personally, nicer. Support our customers in the proactive way that you described. And this is what we are doing. This is where we have set a whole organization for. It's not just some person. The whole organization is targeted for being nice to customers and even end users of the Toshiba hard disk drive. And that's what we also promise for the future.
Yeah, that's something that's really interesting, what you said there about being one of the smaller manufacturers and having to be nicer to your customers. Because Secure Logic very much had the very same sort of ideology, and and we still do, because we're much smaller than your Dells and your HPs. But yeah, that's how we grew our business as well, is offering a better service than everyone else. Okay, well, let's take a look at the next question, I guess, and see where that takes us. So it seems like the next question is, people want to know what kind of hard drives that we use in the machines, and there are so many different types of hard drives these days. I couldn't tell you what the difference is really. Maybe Alex, you can explain a little bit about why you've chosen the drives that we use in our enterprise machines. Please go ahead.
In our industry, which is the CCTV industry, the most important is always reliability. And when it comes to reliability, using an enterprise drive is a must-have. So the differences are vast from, of course, commercially, the price, up to the components in use, the manufacturing process, and pretty much the firmware, everything is different. So having enterprise class drives, first of all, gives us the peace of mind of having 5 years warranty. Also, the client would be translated this to the client, and the client is going to also have this. Is going to make the client always know that whatever happens in the next 5 years, this is going to be covered, this is going to be replaced, or whatever is necessary to be done. Also, enterprise class drives use completely different type of components, and mainly mechanical components. So most of the drives, let's call it for domestic usage, they are not meant to work 24/7, 365 days a year. And that also is based on pretty much the maximum terabytes written, which with Toshiba is 550 annually. Any other domesticated drive cannot reach close to that point, or if they reach it, they will get worn much quicker than what their warranty is being issued. Also, enterprise class drives have completely different type of firmware, which pretty much regulates and optimizes the drive for optimal performance. And something which we always strive for is have a great performance in writing. Pretty much that is covered by the enterprise class drives. And me, as a CTO of our company, those things which I pretty much aligned now are the most important for us. And I'll be very curious to know, Rainer, what do you think from a perspective of a manufacturer? How do you see this put into the perspective of what you do on your daily basis?
Well, we often hear the question, or exactly kind of this question, desktop drives versus enterprise drives. And in fact, one of the issues is, if both are SATA drives, functionally, they're both the same. It's a SATA interface. And you can use a desktop drive in an enterprise environment. It will work. And often people then think, well, if it works, why not do it and save money? Huh? And it's, well, how exactly the manufacturing process leads into quality and what exactly mean time to failure means is pretty difficult to explain. The result is what you said, the lower failure rates, the lower failure rates at higher workloads at 24/7 operation. But I found a good analogy to explain kind of what's the real difference for the end user. You know, it's like the toaster. You can buy for your home a cheap toaster. Well, it toasts bread. You have a 2-year warranty on your toaster. And if your toaster fails within the warranty, they may replace it. You would have to eat white bread for breakfast for a day or two. And if it fails after the warranty time, you buy a new one for cheap money. In the manual of this toaster, there's a small footnote. This toaster is only for domestic use. What I mean is, you can use this toaster for your 200-room hotel at the breakfast lobby. It will work. It will toast bread. But it won't do that much long because of the workload of 300 guests toasting with your domestic toaster. And if your toaster fails, then it's not that you have to eat 2 days of white bread, but you have up to 300 angry guests who have to eat the white bread. This is why there are toasters in the market for commercial use, for use with higher workloads, with more users, more processes over longer times, and higher reliability, because the high reliability is important. It's not just you create a problem for yourself, you create a problem for many other people. If the cheap hard disk drive or the cheap toaster fails in such environment. And if you look at the professional toaster and the toaster for domestic use, you can feel the difference, you can see the difference, although both components do exactly functionally the same. And this is the same for the hard disk drive. The client hard disk drive and the enterprise hard disk drives.
Yeah, I guess the other interesting thing is for the installer, the hard drive doesn't magically turn up on site and replace itself. The site could be 200 miles away. They've got to send an engineer. They've got to get the drive to him. He's got to pull the old one out, put it in. There's a cost involved, even though the drive's replaced for free. So, well, in an ideal world, we'd have no failed drives. No one would have to go to site and change them. That's very interesting. It's a good analogy, and good to know that we're using those enterprise class drives for that for that reason, for our customers and for their customers. Okay, let's look at the next question then. So it seems we have some questions about bigger hard drives, and these days we certainly have some large drives available to us. From my point of view, it's interesting because the camera resolutions are going up. Everyone wants a fast frame rate. Everyone wants the latest 8K cameras recording on their surveillance system. And typically in the past, we would talk people away from it because you needed so many drives for the storage and everything else. So with bandwidths and storage, these days, it's not such a big limiting factor. It tends to be more processing. And I guess drives are only going to get bigger. Maybe you can talk a little bit about the Toshiba hard drive roadmap, if that's okay, Rainer.
Sure. Well, as we speak, we are just introducing the 22 terabyte hard disk drive in this 3.5-inch form factor. And we started with 1, and then now we are at 24. And next year the plan is for 28 terabyte, and then we have a plan for more than 30 terabyte. But all these new developments, it's all about just increasing the capacity. And you can increase the capacity by either adding more magnetic material to write on, or to write the bits denser to fit more. And I brought one typical example of how we came from 18 to 20 terabyte. See, this is an 18 terabyte hard disk drive with the PCB. From 18 to 20, we just added one more platter. One more platter fits here. We shrunk the PCB and can put 2 more terabyte. To 24 terabyte, we increased the recording density by miniaturizing the components. And, well, this has 10 platter. We have a plan for 11 platter. And some basic R&D for even more. And we are also doing a lot of R&D for higher recording densities. Energy assisted with microwaves, or later even with laser diodes. What we can say as of today, looking at our roadmaps and the confirmed product, is that the 30 to 40 terabyte hard disk drive in this form factor, they will come. The only thing we still have to work on for this hard disk drive is not the technology that's there, but we have to work on even the reliability is there. We can confirm that we can probably at some point in time have a 36, 40, even more than 40 terabyte with the same reliability as the 24s today. However, what we are not 100% sure is whether we can manufacture it for the cost that leads to a price that the market accepts. A 40 terabyte drive that costs $2,000 because of the complex manufacturing requires a manufacturing cost of kind of related to the $2,000. No one would buy it because you can buy 2 times 22 terabyte for just a few $100. So this is the kind of major challenge for us as hard disk drive manufacturer. When increasing the capacities, we just increase the capacities. There's no other feature to be improved. It's just more capacity. And this has to be somehow in line with the price. If there is a big jump because of a new technology, as it is always with kind of new materials and with not enough suppliers, production lines and so on, and it comes up with a high premium it's not in line with the just added capacity, there's no meaning of doing a product. So from R&D point of view, from what is technically possible, we can probably have something between 100 and 200 terabyte in its form factor. But we cannot yet confirm that we will be able to manufacture it to the price that you guys will buy it. Yep, that's the point.
Makes sense.
Indeed. But, well, then the question is, those kind of 24, 28, 30, 40, 100, 200 terabyte hard disk drives, how do you want to use it? What's your ideas about that?
There is always a very, very fine line when you design a storage server for CCTV. And as we hear from Ryan, the progress of always a bigger drive comes on an annual basis. The chassis form factor, it does not evolve that quickly because there is a physical limitations that you can never exceed. In 1U, you could fit maximum, a regular 1U, you could fit maximum of 4 hard drives. In a regular 2U, where you're not going into an enhanced depth of the chassis, you could fit only 12 of those drives. So you have your limitations and you need to design it in a very fine and precise way. So having a larger drive on a larger number hard drive system is going to give you a massive rebuild time during failure. But also having a larger hard drive into a system, you could achieve the numbers which the client requires to record for the time he wants to record. So there is an economical advantage and disadvantage. First of all, the larger and the newest drives always come with a premium. And also, what they also save you as to the end user is electricity, because pretty much 3.5 inches drives for the last 10 years, they haven't changed as a consumption. It's anything on full load between 8.5 watts up to 12 watts, and that hasn't changed. So having the same amount of storage using a less electricity on annual basis in a large system is a great benefit for the client, especially when everyone now is on the wave of the green energy and reducing power consumption. On the other side, there is the users which are constantly want better quality footage, more pixels, and they would like to record for longer. So there is always a fine balance between how to design a system. And that fine balance usually gives us the advantage against competitors because we calculate this very precisely and we take this very seriously.
Yep.
I can summarize it pretty much like that.
Yeah. So I actually have a question on what you were just talking about there with the larger drives. You said about adding a platter. I guess one of my questions is, what exactly is a platter? And along with that question is also, does a bigger storage hard drive, so like a 200 terabyte drive in this form factor with all the platters, would it become slower in terms of like read and write speeds and everything else?
Well, that's a very good question. It won't become slower, but it also won't become much faster. So the only optimization criteria we are doing is more capacity for the same cost level.
Right.
We don't optimize on speed because this would contradict. In the past we had this 10,000, 15,000 RPM hard disk drives optimized for speed, but they had lower recording density because of their high speed. Today, if someone needs high speed, he will go SSD anyway.
Mm-hmm.
So although more speed on a hard disk drive would be a nice thing, it would be just nice to have, and as soon as contradict with the higher capacity, we don't do it.
Okay.
However, with higher recording density on the hard disk drive, they're still spinning with 7,200 RPM, and if the recording density is higher, then the bits are smaller and more of the smaller bits flying at the same time. So hard disk drive have in fact increased in speed.
Right.
When they were at 200 megabyte at the outer diameter like 10 years ago, now the 24 terabyte is significantly over 300 megabyte per second. It can still not be compared with SSDs who are at the gigabyte per second, but at least they have been a little bit faster.
Yeah. So the speed of the drive isn't specifically the speed at which it spins. So it's the speed at which it spins alongside how close all the bits are together is your speed. Okay.
Correct.
So I think that's one of those things where you most drives these days are 7,200 RPM. Very unusual to find a 5,400 one these days. But yeah, that's interesting what you say about the bits being close together. Never would have occurred to me. Just thought faster spin, more speed. But guess it's not the case. Okay, interesting. Well, let's take a look at the next question then. So this next question seems to be a bit about AI and video analytics, as that's a lot of our technology partners here at Secure Logic. From my point of view, and where I stand and where I work with these is primarily focused around the GPU and the CPU. And sometimes these days, as we were talking earlier, a bit about SSDs to store these like databases, metadata and that sort of thing. What is your take, Rainer, on where the hard drive fits into, I guess, let's general term it, AI, if you will, as everyone is talking about these days?
I would say today's hard disk drives are the enabler of what we call AI technology today. That sounds a little bit odd, because the hard disk drive just has storage components far away from the compute. But think about it in this way. We already had 2 waves of AI hype in the past. In the 60s, people developed the algorithms. Some of the algorithms we are still working on today. But in the 60s, we didn't have enough compute power. We were running on transistors at that time, and we didn't have any reasonable storage for storing data where artificial intelligence can work on. So just the algorithms. Then there was another hype, I think end of the 80s, beginning of the 90s, where more complex compute CPUs, but also hardware accelerators were developed. So there was another hype of AI, and people were expecting a lot from that, but it didn't fly at that time because we didn't have enough storage. At that time, our hard disk drives had several hundred megabytes and were costing a lot of money. It was okay for the local applications, but not for kind of massive machine intelligence systems. It took us until these days, where hard disk drives in the range of 20 terabyte for just a few £100, plus their scaling in the cloud. Yeah, combining them together in the cloud, having them accessible for the single AI unit, having access to kind of a worldwide data, massive data.
Yeah.
That makes AI in today's commercial models. So the hard disk drive is somehow the enabler. If we wouldn't have the hard disk drive storage available, kind of petabytes and exabytes of storage, we wouldn't talk about AI today.
Yeah.
I should also say kind of the hard disk drive as a rather slow mass storage itself does not really support the kind of excess pattern demand of AI in the best way. But that's the nature of the technology. At least what we have done in the recent years is we have added agility to our hard disk drives. Now, it's a mechanical component. They are somehow slow, but we identified kind of additional agility potential in the hard disk drive, and we have made it available, namely the IOPS. The IOPS of the hard disk drive were never an issue. They were low, and people were using them as hard disk drive as a secondary storage, as a nearline storage. But then with this AI stuff, people want to have them online. People want to have kind of more small data reading and writing. And we identified that there's potential. Yeah, and now with the hard disk drives in reading and writing, there are at kind of 200 IOPS reading, up to 1,000 IOPS writing, which is double from what we had 5 years ago. But the potential was there, and we just made it available. It's still not that much compared to SSDs, but the large AI data storages where you do run the analytics on, they do not consist of just 1 or 2 hard disk drives with their few hundred IOPS. They consist of 4, 12, 16, 60 hard disk drives, or even larger systems, and there you combine the IOPS. So you have a few thousand IOPS where you can run your AI. Yeah, so we have unleashed the AI potential in the hard disk drive over the last years.
Well, that's interesting that you didn't decide to put AI on the hard drive in big letters to let everyone know that. But you're right. Everyone thinks AI models have figured everything out themselves. No, they were just fed petabytes and petabytes and petabytes worth of text, video, images, and sort of constructed their intelligence, if you will, from that. And the thing about the video analytics companies is they're doing the same thing. They'll be putting their video analytics models into cameras or, running in just localized software or VMS. And they're trained as well on loads of camera data to identify a person, a car, a fox, and that sort of thing to make them work. And I was talking to someone, and I can't remember. It's some mad number that you have to put in. You have to show it like billions of people from different angles for it to know what a person is. And, that's all. It might just be JPEGs, right? But if each JPEG is only half a megabyte, that's a hell of a lot of different people you have to show the system. So yeah, that's fascinating because it's never really occurred to me that the hard drives played actually a super important role in this latest generation of hardware developments for AI and machine learning.
And it's good for our business, as you said. They needed an enormous amount of data. And you do not know what data you need, so people save everything.
Right.
In your business, they save all the footage. They don't stop the recording because of saving space. They just record everything. You do not know what you use it, what you would need it for.
Yeah.
And this boosts all our business.
Just keep it, just in case, right? Just in case. That's great. All right, well, we'll continue on to the next question then. Okay, this next question is about Moore's Law, and does it apply to hard drives past, present, and future? For anyone who doesn't know, Moore's Law is that the capacity performance of a hard drive will double every 2 years at minimum cost, and that is also relevant for processors, GPUs, and everything, all other kinds of technologies. Rainer, I think you're a bit of an expert in this. You've been around hard drives for a very long time. I think you're probably best placed to talk about this, if you wouldn't mind.
Sure. I mean, if you want to know how we came and where we go, let's look a little bit into history and future. Actually, when we launched the 20 terabyte hard disk drive 2 years ago, in the year 2022, I thought the 20 terabyte is a kind of anniversary of the hard disk drive. Yeah, and I checked in our museum, in our labs, about what was 20 years ago. And in fact, exactly 20 years ago, in the year 2002, we introduced the 20 gigabyte 2.5-inch hard disk drive for laptops, which was a good drive at that time. Remember the laptops we had. And another 20 years back, in 82, Toshiba introduced a 20 megabyte hard disk drive for this IBM type of PCs, a brick like this with just 20 megabyte. So all of these, the 20 terabyte of today, the 20 gigabyte 20 years ago, and the 20 megabyte 40 years ago, were appropriate hard disk drives for the application we were running. Today, like cloud usage. Many users, many photos, many movies in the cloud. 20 years ago, our laptops with some office programs, 20 gigabyte was enough. And 40 years ago, we didn't have even colored monitors. We didn't have any digital pictures, just kind of C and Pascal coding and ASCII characters. 20 megabyte were enough. That means every 20 years, a factor of 1,000. Sounds like Moore's Law.
Yeah.
If you break it down. And that's 40 years of confirmed history. It's there. Now, if we think about kind of development, just continues as it did with that pace, not even accelerating. Often development is accelerated, as we know. Just continue. Then, according to that pattern, we should have a 20 petabyte hard disk drive in the year 2042. 20 petabyte. That's 3 to 4 data center racks. I cannot imagine this fitting into a size of this. It's
Crazy.
I mean, back in 82, 2002, we didn't even think about 20 terabyte. No one has seen 20 terabyte. No one thought about. No one even knew what a terabyte was. Today, all of us have seen 20 petabyte on one spot. The 3 to 4 data center. So we are one step ahead. And by the way, in the year 2042, I will be 76. So please take a note in your calendar. We should do a session again and review it.
Yeah.
And we were 40 years back. Let's go 40 years in the future. So in the year 2062, we should have 20 exabyte in a form factor like this. 20 exabyte is about 3 to 4 data center halls. So we know what an exabyte is, and we have seen exabytes physically. Again, not the clue of an idea how to squeeze it in a form factor like this. However, it's probably not spinning disks. But there is research on public organizations done in alternative storage technologies. For example, in Switzerland, they are doing some major research on coding data on quartz nanocrystals. And according to their results, they can do so and so many terabyte on the size of a coin. And if I take their results and calculate my 20 exabyte in 2042, how many coins? That would be roughly the size of a chocolate bar. Chocolate bar. The media is there. We have to work on reading, writing, we have to work on kind of economics, but it's not out of the blue. And easily, the 20 exabyte 2062 are, the oldest and most stable and advanced storage technology is DNA. It was used even before humans were there. It lasts 20,000 years. And people, in fact, have tried to code digital data on synthetic DNA. Well, they did a few gigabytes. It cost them a few $1,000s. Probably not that most economic storage technology. But according to the results of these experiments, 20 exabyte would fit in a 100 milliliter yogurt can. It fits.
Yeah.
Well, in 62, I'm 96.
And yogurt will be the only thing you're able to eat?
Well, let's schedule a review in 62.
Yeah. That's very interesting. Very interesting. Okay. Well, I guess we'll move on from that. But yeah, I look forward to seeing 20 exabytes in a yogurt pot. I do think it's interesting because a lot of people won't even know what a petabyte is. A lot of people will if they're in the industry or IT and that sort of thing. But exabytes, that sort of next level. And I think what you're talking about is we're already aware of those numbers existing. So it could be far beyond that in reality. Okay, interesting. Okay, we'll carry on then and move on to the next section. So let's finish this webinar off with something a little bit different. Can you tell us what the largest and smallest hard drives you've experienced in your career is, please? Could you speak to that?
Sure. The largest is obviously the current model. So it's currently 22 and soon we are selling 24 terabyte. That's an enormous amount of data. It's used in cloud data centers, it's used in storage servers, surveillance servers for big infrastructures. However, hard disk drive have been used in many other components and many other products in the past. For example, this is an iPod Generation 1 with a 5 gigabyte hard disk introduced in the year 2000. MP3 player, portable equipment, and it was using a Toshiba 5 gigabyte hard disk drive. This model. It fits. See? It was basically the enabler for the 1,000 songs in the pocket dream of Steve Jobs. Well, today's MP3 players don't use hard disk drives anymore. No one is carrying hard disk drives around. We do not carry them in our pockets. Flash is the better, not the cheaper, but the better storage technology for that. But remember, we were carrying hard disk drives. It even went to the extent, this one here. This is in fact the physically smallest hard disk drive ever manufactured. It's a spinning disk with a SATA interface. One platter, one head, 5 gigabyte. And it was used in mobile phones. In the year 2004, a company called Nokia introduced what they called the music phone, N91. And it was equipped with a Toshiba 4 gigabyte hard disk drive, which is still spinning in this mobile phone. But let's see. I think it may still work. That's MP3 and music from the portable hard disk drives. But soon after that, also the technology changed, and nowadays we all use the flash. Yeah? But again, the fact that we don't carry the hard disk drive around with us anymore does not mean our data is not on hard disk drive. Our data, even today, is on hard disk drives. In the central IT, in the cloud, and on secure Logiq servers.
Yeah, so essentially hard drives are still the main long-term storage for everything, even though we don't carry them around with us anymore. We're just transferring the data off into different directions to be stored on someone else's hard drive. I noticed you didn't have any Taylor Swift on that phone, though. That's only for the cloud, right? That's only for the cloud.
Well, I don't think, was Taylor Swift already born in 2004?
Today, write in the comments or something. Okay, brilliant. Alex, do you have anything to add? This is like really interesting. I've certainly never seen a hard drive that small.
I think hard drive that small, and that's a beautiful example of how technology was and where is it today. But this is beautiful piece of engineering, and when I look at it, for me, it's not hard drive. For me, this is like jewelry.
Yeah,
I just love it. It's beautiful.
Okay. And any other manufacturer phone probably wouldn't still be working after all this time. I mean, how many times have you dropped that?
Oh, as a normal phone, you drop it.
And the hard drive still working?
Yeah.
Brilliant. That's really, really interesting. Thanks, Rainer. We appreciate that. And we'll bring the webinar to a conclusion for now, and then we'll move on to some questions and answers from here. Okay, so on to the questions that have come in then. We'll start off with the first one and go as they've come in. So someone's asked about the mean time between failure of the hard drives being 2.5 million hours, which equates to more than 200 years. So why isn't the warranty longer on the hard drives?
Mean time to failure or mean time between failure? First of all, for hard disk drives, it's mean time to failure because they fail only once. Mean time between failure is a term that, strictly speaking, relates to repairable equipment like cars.
Right.
Now, 2.5 million hours, 220 years. That's kind of this statistical value until one hard disk drive fails within the operating condition. And the operating condition is 5 years warranty time. So within the warranty time. So that does not match at all. So this mean time to failure is a really unhandy value. Now, let's say 220 years. You can put it in a way that if you have 220 hard disk drives in your system or in the servers that you are running in the field, then you can expect one failure every year.
Right.
Or you can translate the 220 years or 2.5 million hours into an annual failure rate. And this is 0.35%.
Right, okay.
There's another analogy that makes it really clear. Let's say my personal mean time to failure or annualized failure rate. I've once asked my life insurance, they have tables for that. That's an important value for them. They have to budget how many they have to pay, right? And they said, my personal annualized failure rate as a 56-year-old person in healthy, medium sports, medium alcohol, no dangerous spare time activities, is 0.18%. That means out of 1,000 contracts of my specification, they expect 1.8 fails or death in the next year. That translates into a mean time to failure of me of 5 million hours.
Okay.
Like 400 years. I won't live 400 years. Yeah. But 1.8 of my specification may die in the next year. Probably it won't hit me, but it could. This is why I have a life insurance. And hard disk drives having a similar reliability like me, your hard disk drive won't fail in the next year. But it could happen. This is why you should do a backup.
Yeah, or have a RAID array. You explained to me how you test this mean time to failure a little bit previously. Just nice and short. Can you just explain how you physically do that with your drives?
When we launch a new series, we do a large population of sample drives, and we test them for up to 1,000 hours. That's 3-4 months is kind of, and we do this as a burn-in testing. So with kind of highest workload, higher temperature as a kind of accelerated wear out, in order to confirm that in the development we have done everything right, that we can commit to this 2.5 million hours. And we are doing this again and again to also confirm the test time of the drives we need and to reconfirm the quality.
Yeah. Thank you. Another question here. Why don't you use SSDs for storing video footage? I'll pass this over to Alex, but I'll just give a really brief explanation first. Is basically that it's the longevity of the drive. They don't like to be overwritten constantly in the same way that hard drives do, or the same way that hard drives can withstand that kind of data and overwriting. Alex, do you want to talk a little bit about why we shouldn't use SSDs for big storage for video?
First of all, it's economical reasons. To use the same size storage, which let's say hard drive comprises, and what you could use as a flash storage is in times more expensive and pretty much it's not commercially viable. That's one of the reasons. And the other reasons, there is a different type of flash storage. And then there is a rating on the flash drives, which comes with drive write per days. And considering that sometimes the intensity of the writings are way above what the drive is rated every day, you pretty much are going to shorten the life expectancy of that drives with, we think, pretty much months. Especially, let's say you have a heavily loaded database, which have hundreds of thousands of instructions per second going through and data written. And these drives would be destroyed within probably weeks.
So more expensive and won't last as long.
Absolutely.
Is basically the rules for SSDs.
Yes.
Yeah. Where are they good? Where should you use an SSD?
SSD, you should use only if you require a very high IOPS and a lot of throughput. But usually in the current system and how most of the things are designed, you will exceed what the throughput on the RAID or HBA card is, which these devices are connected, much earlier before you exhaust the potential of delivering throughput and IOPS. So again, when you construct the server, you need to think much earlier what you want to achieve, what is the final result, what is the target price which the client would like to see, and then you need to pick up the components very carefully.
Because we tend to use them for the operating system, so you keep your operating system boots up really fast, your application drives, where you don't need a huge amount of storage and you're not overwriting constantly, but you get the benefits of that fast performance. It's really noticeable, isn't it? Okay.
Yes.
Okay, the next question here, we were talking about helium drives earlier. Beyond the helium drive, what are the technology advancements in HDD storage we can expect going forward?
Okay, let's say for the 30 to 50 terabyte hard disk drive, we will use energy assisted magnetic recording, namely this heat assisted. So these laser diodes can be miniaturized much further than the current microwave oscillators. Well, there's even potential beyond that. It's just a question of kind of how cheap we can manufacture it. As said earlier in the session. The 100 to 200 terabyte, there is an idea of moving away from a continuous magnetic media to let's say, dots, individually formed dots, magnetic dots in the nanometer scale. That will give another boost, probably 100, 200 terabyte from physical point of view. But there we need a different manufacturing process, like a lithography process, an expensive lithography process. Whether this will be will make a commercial sense, we don't know yet. But if industry manage, then it will be a heat-assisted analytic recording with single dots in what, 10 years, 15 years or so.
So in the near term, 5, maybe up to 10 years, probably not going to see any big changes in the hard drive technology as such.
No, even the form factor will remain the same. There were ideas of making a double height with 20 platter, but then you have double the capacity, but also double the space. And you have no servers, no base, no trays that fit in. So this idea was dropped. There was an idea of having other interfaces or so, having a dual actuator. All these were dropped because of people just want capacity.
Yeah, so they're pretty happy with the hard drive as it sits. They just want bigger storage. There's another question here. It must be from the same person here. And what about the next advancements in server technology? I think that's a bit like the hard drive, really. We're going to have CPUs and RAM and the same sort of configurations for a long time. I think it will be newer technology, like specific, lots of technologies coming out at the moment for specifically using, like running AI models. They can buy specific PCI cards to do this kind of thing, and I guess that will gradually creep in. And we already have GPUs in servers. It's not as common, but it's becoming more common. Have you got any thoughts on that, Alex? Like what the latest, the next server technology will be that's creeping into the industry?
When we say server technology, we need to consider all the components which comprises, let's say, an ordinary server. Now with AI on the horizon, it's not on the horizon, it's now present, the data is going to go exponentially up. And when I say exponentially up, that means like in geometrical progression constantly. So the further we progress in AI and the further we develop, the best AI models would be the models which you've thrown a maximum amount of information in and out. And that always requires enormous amount of storage. I personally believe any manufacturer of storage, if flash storage or hard drive storage, they need to increase their production capacity in the next 1 to 3 years. Otherwise, the demand which the market would have and the implication is going to have over companies like ours would be massive, for the reason that manufacturing lanes, they could be tweaked and optimized for certain type of drive sizes, certain type of technology, and certain type of generation drives. So manufacturing the largest drives currently available to market, let's say 24 or 26 or even upper, would be the most desired from the manufacturing point of view, because that there is where most money is. When you go for a smaller capacity drives, that is going to be put at the back of the queue, for the reason that economically it's going to be a lot easier to earn more money manufacturing the largest drive, and the largest drive would be the one in the demand for the AI. And currently the AI and what is being thrown to the AI from the big companies, like massive companies worldwide.
But I can relieve your concern to some extent. When we launch a new generation, let's say 20 terabyte or 22 terabyte or 24 terabyte, from time to time, we do a relaunch of the older legacy capacity points with the same technology. Because today, with our 10th generation, which was intended for 20 and 22 terabyte, we can also make a much better 4, 6, and 8 terabyte. And we are doing this. That means on the same platform, we can make 2, 4, 6, up to 10, and 18, 20, 22 terabyte with the same material. So as long as there's a demand for the smaller capacities, we can just take it from the same production line and manufacture it. So we are not forgetting about our legacy and customers who need legacy drives. That's the market for us, and we are supporting that, even with new developments. Recently, we have launched a new 1 terabyte out of the 10th generation. a new 1 terabyte. That's still demand for 1 terabyte hard disk drives, and we are manufacturing and selling them. Don't worry.
Yeah, I guess that's the thing. People also need smaller, more cost-effective drives when they don't need to buy the latest 16, 18, 20, 24 terabyte drives. Yes, that's nice to know. So a good one for you here, Rainer, and something we spoke about before, and you told me something really interesting. Does sudden power outage damage hard drive or indeed a server? You want to talk about the hard drives on that?
The hard drives have protection mechanism about sudden power outage. So what all our hard drives are doing is, if the power suddenly drops, we are using the kinetic energy in the spindle. We are switching from motor to generator.
Mm-hmm.
And in the rotating spindle, there's enough power to close all the electronics, kind of to write everything into small flashes, to clear all the buffers, and caches, and also to park the arm on the ramp. This is very important. The arm must not stay on the platter, otherwise you will have a head crash. And this is for all hard disk drives. So the sudden power outage does not damage the hard drive, nor causes data loss. Because at the next spin up, we are writing the data that was put into a small flash onto the media in order to have a consistent state then.
Well, yeah, I didn't know that before. That's crazy. So basically, you're using the platters as a big flywheel to generate what's their kinetic energy into electrical energy, so that you can safely shut down the hard drive specifically.
I mean, if you do this very often, let's say every minute or every day, several times, then you will create a reliability concern. Yeah, it won't fail, it won't malfunction, but it will impact the long-term reliability. In fact, the best thing for a hard disk drive is like the old taxi cars. If they run all around the clock, the oil never cools down. Then they run for kind of 3-4 million kilometers or miles. It's the same with the hard disk drive. Kind of the best operating condition for a hard disk drive is to switch on once and to switch off after 7 years. And we, in fact, have some data centers where I see hard disk drives in operation since 7 years with 2 power cycles. This has the lowest failure rate for hard disk drive.
Okay, so the drives are obviously really reliable. We talked about with the mean time to failure, and also they have this feature built in if they get like a dirty shutdown. But the truth is, with any server hardware and the components, particularly hard drives or anything else, having the server installed in the correct environment with a UPS, with proper air conditioning, with proper maintenance, then you should have really good longevity out of your hardware in general. And you know, if you are fortunate and something does happen, you do lose all the power, you've still got all of the fail safes there, as you mentioned, with the drives, and other server hardware is also you know, capable of handling those shutdowns as well, and it's not regularly. Okay, what's this one? What are the different types of recording technologies used in storage drives? Rainer?
Well, in the past, we had longitudinal magnetic recording. So the data was in a horizontal way, of north and south magnetized. This was the kind of smaller gigabyte hard disk drives. In the 2000s, we introduced the perpendicular magnetic recording. Perpendicular means the bits are now horizontal, kind of flip north, flip south. This is the terabyte hard disk drive of today, and we sometimes call this conventional magnetic recording, like PMR or CMR. And actually, we are using this technology still today. Even this hammer, whatever, the base technology is conventional or perpendicular magnetic recording. It's just that in order to make the write head even smaller, we cannot miniaturize it without additional energy, otherwise it won't be able to flip the bits.
Right.
So the newer technologies, they just add on top of the perpendicular magnetic recording, they add additional energy. either with a microwave, then it's MAMR or microwave assisted magnetic recording, but below that it's still perpendicular. All heat assisted with the laser diode. There is just one other technology which is kind of beside this. It's not a different technology, it's just beside this. It's the shingled magnetic recording. So the shingled magnetic recording is also perpendicular and may also be heat assisted or microwave assisted, but shingled magnetic recording means that you write overlap tracks in order to have more dense data, which has other implications. But kind of it's not one or the other technology. It's always perpendicular, on top, energy assisted, and aside of this, you either write track beside track or track overlap track, and then it's called shingled magnetic recording.
Okay. Wow. That was for a question that I didn't understand when it came in there. That's a good answer. And so we've got one more question. Which recording technology would be more effective in achieving a drive capacity of 40 terabytes to 50 terabytes?
We don't know yet. We think, no. A long time we thought it will be microwave assisted because that's a proof technology, material is available. Yeah, but we cannot really miniaturize it in the microwave. We would need even more platter. So at the moment, there's a tendency for the, say, 30, 40 terabytes towards heat assisted. Yeah, because we can write much denser. So we need less platter for the 40 terabyte. So as of the current roadmap and planning, probably heat assisted magnetic recording.
Well,
but well, it may change.
Yeah, there could be some other new space technology that we haven't discovered yet.
Not really, but kind of the exact technology to be determined is also it's always a matter of kind of what is available, how far is it advanced, is it reliable enough, and most of all, can be manufactured for the price you guys are willing to pay.
For a palatable price of hard drive. Yeah. Okay, well, I think that is our final question on the list here. So thank you guys so much for doing this with us. It's been really interesting. I think everyone will have got a lot out of it, and I'll bring it all to a close there. Cheers, guys.
Thank you.
Thank you.
Thank you.